This is section 5.7a, solving quadratic equations by completing the square, page 19 in your notes. And this is our third method for solving algebraically. Completing the square, kind of based off of that worksheet that you guys were focusing on before, is this idea of needing to find some missing piece to a square that we know. So we know that the outer sides here are x and x. We even know that this number is, say, 5 and 5. So we need to figure out how much area needs to be in this shaded part to make it work. We looked at some patterns for this before, and your patterns are that you're always going to look for ax squared plus bx plus c. And we said that you're looking for half of your b term, and once you get half of it, you'll end up squaring it to get your c term at the end. So right now, I would like you please to just follow along with the method, and we're going to see again how this comes through to tie back to the group work. So first of all, for completing the square, you're going to have some sort of special equation on the left-hand side, and this is different. Does not have to equal 0. We'll talk about that in a second. See how that actually gives us a good answer. But it does not have to equal 0. This is the only method, completing the square, where that's true for us. All the other methods has to be equal to 0. This one, we don't need it to be equal to 0. What we do need is we need this left-hand side to factor nicely. So we'll just leave that 9 out there for a second. Now, looking at your trinomial, we know that we have to have x's in the front, and then at the back it's a 36, so it'll probably be 6 and 6. It's a positive 36, so it has to be same signs, but it's a negative 12, so negative, negative. Check it. X times x is x squared. X times negative 6, so negative 6x. Negative 6x, that's negative 12x, good. Negative 6 times negative 6, positive 36. Awesome. Now, once you have factored, that's step 1. Step 2 is to go ahead and write it as x minus 6 quantity squared equals 9. So you actually write those two pieces together with a squared. We're solving for x, and now we just want to try to undo the pieces. So this 2 here, we're going to undo that by taking a square root. And again, we put in the square root, so we should have a plus minus in front there. So we'll end up having the squared and the square root canceling, which leaves us with just x minus 6 equals plus or minus square root of 9 is 3. Move the 6 over, so we add 6 to both sides, and we end up getting x equals 6 plus or minus 3. Now, this actually gives us two answers, because we have x equals 6 plus 3 and x equals 6 minus 3. So we end up getting 9 and 3. Notice again, we get two answers. This whole chapter, we've been getting two answers for our x's. So these two numbers here, if we take and plug them back into the equation, it should make it work. Sure enough, if you have your calculator and you plug in x equals 9 to your x's, you'll have that the equation equals 9. And if you plug in a 3, it equals 3. So we call those our solution points. So that's your method. 1, factor it. 2, put a squared. 3, you take your square roots. And then make sure you have your plus or minus in here from your square roots. And then 4, go ahead and move all the terms over so you get x by itself. And then 5, you split it up into your two answers over here. So here's our steps for this one. We want to factor this left-hand side. It's a 4x in the front, so let's try 2x and 2x. It's a 1 in the back, so we don't have any choice. And they're both positive, so it should be same signs. And this equals 25. Let's see if this works. 2x times 2x is 4x squared. 2x times 1, 2x, plus another 2x, so 4x, good, and then 1, 1. All right, so step 1 is good. Go ahead and write them together. 2x plus 1 quantity squared equals 25. We're going to take the square root of both sides, and we're going to slip in a plus minus. When we do that, the squared and the square root end up canceling, so we have 2x plus 1 equals plus or minus. Square root of 25 is 5. Now we'll just start moving our pieces over, so subtract the 1. So we end up getting x equals negative 1 plus or minus 5. Excuse me, there's a 2x there. So we need to divide both sides by 2. So we have x equals negative 1 plus or minus 5 all over 2. When we split this up into two answers, we get x equals either negative 1 plus 5 all over 2, or we end up getting x equals negative 1 minus 5 all over 2. Negative 1 plus 5 is positive 4. Positive 4 divided by 2 is 2, so that's our first answer. And then x, let's see, negative 1 minus 5 is negative 6. Negative 6 divided by 2 is negative 3. So our two answers are positive 2 and negative 3. Plug those back into the equation, they will make it balance. Now, notice in your two examples that we just saw here that it worked really nicely to get these factorings because it was a perfect square trinomial. We've seen these before when we're factoring, but as a reminder for us, a perfect square trinomial is when you get something that's a plus b quantity squared or a minus b quantity squared. And in order to get that, you end up having certain patterns for them. We talked a little bit about how it's a perfect square in the front, a perfect square in the back, and then double the factors of that in the middle. Some examples, though, do not have this lovely pattern. So take a look at something like this. Let's say you have x squared plus 6x plus 11. It doesn't follow this nice pattern here. We know that half of 6 is a 3. We would actually be expecting a 9 at the back, but instead we have an 11. What do? The method of completing the square converts an equation into a perfect square trinomial. So it takes something where there is an 11 at the back, and it helps us get something useful like a 9. Here's what I mean by this. What would be the perfect number to get something factored really nicely for this one, so we could get something squared? In our worksheet, we saw that you could take half of your 20, which is 10, and once you take 10, you square it, and that gives you 100. So that is the perfect number to squeeze in there, meaning we could get x plus 10 quantity squared. Next one, half of negative 18. So negative 18, take half. Negative 18 and half would be negative 9. And then we all want to square that number, so we get positive 81. That would be the lovely number at the back. What do we need to have in here then? We'd have x minus 9. Notice that this was a minus. This will also be a minus. Maybe you can start to see the pattern here. Take half of my negative 5, and then we'll square that. So half of negative 5 is negative 2.5. Square it, and we will end up getting 4.25. Excuse me, 6.25. And over here we'll say x minus 2.5. All right, half of 7. And then we'll square that, so we end up getting 3.5 squared. And 3.5 squared is 12.25. So we say x plus 12.25 squared. So again, our pattern for this one that we're seeing is we're always taking whatever this middle term is, and remember how we said that there's an a x squared plus bx plus c. In order to get from b to the perfect value of c, we will take b and cut it in half and then square it, and that will give us the number that makes it really nice to factor. So let's use that on some of these equations that don't start out perfect. For example, this one right here, x squared plus 4x plus 1. This is not going to factor really nicely, and we can tell that. So we can tell that because this plus 1 here is in the way. So what we're going to do is we're actually going to just move this guy over. We're going to put him on the other side of the equation and make a space. So we have x squared plus 4x plus space equals, and it's a positive 1, so subtract 1, negative 1. And then we'll say, okay, what do I need following this pattern from up above? What do I need here? So we will have half of b and then square it. Half of b would also be 2, and 2 squared would be 4. So that number is what we put here. Now remember that if you add anything to one side of an equation, you have to balance it by adding the same thing to the other side. So we'll add a 4 over here. Now that we have something nice and perfect, so we have x squared plus 4x plus 4, we'll factor that. So we get x plus 2 times x plus 2, and negative 1 plus 4 is a 3. Again, rewrite this so it's x plus 2 squared equals 3, and now we can start undoing those squares with squared roots. Make sure you have your plus or minus. Cancel the squared, cancel the square root. So we have x plus 2 equals plus or minus root 3. Isolate your x, and this gives us x equals negative 2 plus or minus root 3. That's okay as your answer. Remember, this actually splits to two answers. It means x equals negative 2 plus root 3, and x equals negative 2 minus root 3. That's what those two answers mean. Let's see another example like this. Now, this one, there's already kind of a space for us here. X squared minus 3x plus space equals 4, plus we will add the same thing to both sides. So whatever we end up putting on the left, we'll put on the right. We need to take half of negative 3 and square it. So we end up getting negative 1.5 squared. And 1.5 squared is positive 2.25. So 2.25 here, 2.25 there. This means that now we can factor this left-hand side. So we end up getting x, remember it's always half of that b value from our pattern, so x minus 1.5, x minus 1.5 equals 6.25. So x minus 1.5 quantity squared equals 6.25. Square roots, plus or minus. Cancel the squared and the square root. We get x minus 1.5 equals plus or minus 6.25. And let's check that one really quick. Square root of 6.25 is 2.5, so plus or minus 2.5. X minus 1.5 equals plus or minus 2.5. Move the 1.5 over. And so we get x equals 1.5 plus or minus 2.5. Again, that means two answers. It means x equals 1.5 plus 2.5, and x equals 1.5 minus 2.5. So our first answer will be 4, and our second answer will be negative 1. Those are the two solutions for x. All right, sometimes you have numbers that are in the way, and they're just not the right number. We saw this in one of our first examples, so move him over, make a space. X squared minus 8x plus space equals, we're subtracting 36 to both sides here, so negative 36 plus blank. And then we need to get this middle term, so half of 8, and then we'll square it, which is negative 4 squared, so 16 to both sides. When we factor it, we have x minus 4 quantity squared equals negative 20. When we square root both sides, notice, still a plus minus, notice that all of a sudden we get a negative under the square root. We have x minus 4 plus or minus negative 20. But we've seen imaginary numbers, so we know what to do with that. We know that this becomes plus or minus I root 20, which then becomes plus or minus I. If we break up 20, this is 4 times 5, so 2I root 5, and this is still x minus 4 here. We'll add the 4 to both sides, and we get x equals 4 plus or minus 2I root 5. We can't put the 4 and the 2I together because one is a real piece, or this is the real component, and one is an imaginary component. So we just leave our answer like this. Again, it means two answers. It means x equals 4 plus 2I root 5, and x equals 4 minus 2I root 5. Those are the two answers that this means. All right, and another one, this time with a little bit of a minus in front. They left us a space, x squared minus x plus space equals 2 plus space. When we take 1/2 of that b term here, so this is really a -1, so half of -1 squared equals positive 1/4. So we're going to be getting some fractions and decimals. We'll go ahead and say this is x minus 1/2 squared. 2 plus 1/4 is the same as 2.25. I'll do some square roots in here, plus or minus. So we have x minus, since this is a decimal, I'm going to change this to a decimal just so it matches. Plus or minus, the square root of 2.25 is 1.5. So we have x minus 0.5 equals plus or minus 1.5. Add 0.5 to both sides. X equals 0.5 plus or minus 1.5. Again, two answers. X equals 0.5 plus 1.5. X equals 0.5 minus 1.5. So x equals 2. And x equals -1 as your solutions. It's okay to get i's. It's okay to have decimals. It's okay to have fractions with these. Just means you need to take a little extra time to finish them up.